Okay, this is U7B homework. This is exponential equations not requiring logarithms. So we will be doing the same worksheet similar to this with logarithms later. Right now this is without. So right now you'll notice that you have the same family of 2. So your first step is you want them to have the same base. So in this first problem, the base is the same. So that's good. So we can avoid step 1. Step 2, if they do have the same base, set exponents equal. So we're not going to look at the 2's here. We're ignoring these. We're going to set 2x equal to 3x. 2x plus 2. Set your exponents equal. We can ignore the bases and set your exponents equal. Then we're just solving for x. So step 3 is solve for x. So we're going to subtract 2x to both sides, and x is 2. Done. Step 2. So we have 3 and 27. In order to put these in the same family, we have to find out which family it is. So the family that we're going to put these in is family of 3. So there's no change to the left side. But on the right side, we can change 27. You should know that 3 cubed and 27 are the same thing. So we're going to replace 27 with 3 cubed. Now you'll notice that they have the same base. So you kind of like ignore these. You don't look at those, you set the exponents equal. So you have 1 minus 2x equal to 3. Subtract 1 from both sides. Divide by negative 2. And your answer is negative 1. So the next one. We got to put these in the same base. So what number base do you think you could put both these in? Since they end in 5s, most likely it's going to be the 5 family. So some little things that you need to know is that 5 squared and 25 are the same thing, and that 5 cubed and 125 are the same thing. So if we had a chart, you could find the 5 family like this. So 25 is going to be rewritten as 5 to the second. That's 25. But there's this x plus 2 up here that is not going to go away. So you just put that next to the 2, and the 2 will have to be distributed. Now the 125 side, that should be 5 cubed. But there's an x plus 1 with that one, so times it by x plus 1. So you're going to ignore the bases, and we're going to set 2 times x plus 2 equal to 3 times x plus 1. And we're going to distribute. So this is 2x plus 4 equals 3x plus 3. Now to solve for x, you want to get the x on the same side, so I would get rid of the smaller x term first. So you have 4 equals x plus 3, and then subtract 3, and x is going to equal 1. So what family do you think 4 and 8 might both be in? So over here, you should know that 2 squared is 4 and that 2 cubed is 8. So they're in the 2 family. So 4 is going to be written as 2 to the second. But there's this 2x plus 5 up there, so you're going to be distributing the 2 with the 2x plus 5. 8 is really 2 cubed, so this. But there's already a 3 up there. So there's another 3. So it's 2 cubed cubed. 8 is 2 cubed, but this was 8 cubed, so this is still 8 cubed. So it's 2 cubed cubed. So we're going to write the base ones. We're going to distribute this. And this one's going to be base 2, and you're going to multiply these, which is 9. Ignore your bases. 4x plus 10 equals 9. Set your exponents equal. Subtract 10. 4x is negative 1, and x is negative 1/4. Because that one's kind of a weird one, let's see what would happen if we did this one on our calculator. So let's go back to the original problem for 4. In y1, I want you to type in 4 to the 2x plus 5. So let's do that. So we're going to type in 4 caret 2x plus 5. So it should look like that. In y2, we're going to type in 8 to the third. 8y to the third. And we're going to graph. That's the first one. And I'm not going to see the second one because it is 8 cubed. That's humongous. I'm not even sure what 8 cubed is. So I'm just going to go to Window. And I'm going to change my Y max I'm just going to change it to 1,000. I don't know what 8 cubed is, but I'm pretty sure it's pretty big. So I'm going to 1,000. So here's the first one. Heck, I don't know. Oh, there it is. So I did see it. You guys see it? It kind of took forever. So I want to see they're intersecting right there. So we're going to press second trace, number 5, enter, enter, enter. And you guys see right down here at the bottom where it says negative 0.25? That's our answer. Negative 0.25, which is the same thing as x to the negative 1/4. So you can also write negative 0.25. So do you want to try the next one? Since we have the calculator out. Let's press 3 to the x. Oops, let me clear this out. So let's do it again. 3 to the x. And 81 is raised to the parentheses. No, we don't need parentheses. 2x plus 3. Some of you might need parentheses. But this calculator is the newer one and it just goes up there. Make sure the 2x plus 3 is in the exponent. Let's graph. Let's see if I'm still on that same graph from the last one, so it's a crazy graph. See this down here? It's so, oh, I don't like this. So I'm going to go back to a Zoom 6 screen. Let's go back to a Zoom 6 screen. This calculator is slow. It looks like it's intersecting like over here. Let's see if the calculator can pick it up. Second trace. If not, we might have to make this a different graph. 1, 2, 3. It says negative 1.74. I'm going with it. Negative 1.74. Let's see if we can get that on our calculator. So we have 3 to the x. Oh my gosh, this is so blurry. What happened? So I can write 81 in the 3 family. So we're going to keep 3 to the x. 81 is 3 to the 4th times 2x plus 3. So we have 3 to the x equals 3 to the 8x plus 12 if you distribute. When the bases are the same, which they are, you're going to set x equal to 8x plus 12. Subtract 8x. You get negative 7x equals 12, and x is negative 12/7. Let's see what that looks like. So hopefully that's negative 1.74. So negative 12 divided by 7 is, voila, negative 1.714. I had 4, so I don't know if I just didn't read that right. So it's negative 1.714. I don't think that one's right. What family is 49 and 7 both in? It should say 7 family. 7 doesn't need to be simplified, but 49 can be rewritten as 7 squared times the x minus 1 that's already up there. Same base, ignore the 7's, set the exponents equal. I'm going to distribute the 2, set it equal to 4 plus x. Subtract x, add 2, x is 6. Graph e to the 2x. This should be a growth, so it should be going up. So this is e, second division, raised to the 2x graph. Go to Zoom 6 screen if you're not already. That's what the graph is. I want to graph 3 points. So 0, 1 is that key point. Remember, 0, 1. Find 0, 1 on your T table. There it is. I like everything to be centered around 0, 1. So 0, 1 for sure. There's my 0, 1. Now, what's 1? 1 is, well, actually, my T table is not set up right. So second window, I'm going to second window. I'm going to start at 0 and go by 1s. I went second window for a table setup. Second window. Started at 0 and went by 1s. So I have 0, 1. I have this 1 and 7.4 right there. So that 1 and 7.4. So 1 and 1, 2, 3, 4, 5, 6, 7.4. And the negative 1 looks like about 0.14. It's really small. It's enough for me to draw my picture. That's what an exponential growth looks like. So this next one should be an exponential decay. It should be a decay because of the negative exponents. Let me clear this out. We have 3e caret negative 2 to the x. This should be a decay. Should start high and come down low. There it is. Now usually 0, 1 is a point, but it looks like 0, 3 is a point. That's because you have a vertical stretch of 3. So that's why it's going to be 0, 3. So let's start there. 1, 2, 3. Without even looking at the t-table, you should know 0, 3 is a point because of the vertical stretch. But let's just look at our t-table. Find 0, 3. There it is. You see 0, 3? I'm going to graph 1 and 0.4. And then I'm going to graph negative 1. Ooh, negative 1 and 22. I'm not sure I can get that in there. It's way up here. So it's just really high. So your graph looks something like that. That's it.